Hello, dear students. Thank you so much for inviting me in your home. I would like to take time to explain to you a little bit about inside our planet. It's sort of like both as teaching and also review, because we covered that subject earlier, but not in so much detail as I'm about to this time. Let's look at inside our planet. Now, what is our planet like? Now, as you can see here, as Earth cooled, most of it turned to solid rock. And I'm going to tell you one thing that I'm going to cover in just 5 minutes. I will only take 5 minutes of your time, no more. So here we go. Let's have this journey together. As Earth cooled, most of it turned to solid rock. It formed layers with the heaviest material at the center, the core, surrounded by a deep rocky mantle and a thin brittle crust. Nuclear reactions inside the planet make the rocks much hotter than their normal melting point. But intense pressure keeps the rock solid, except for the outer core, which is liquid. Now, as you can see, here it's outer core, and right there you would see inner core. I will just make it more clear for you. Outer core, inner core, yeah. This is mantle, outer core, inner core. Now, as you can see, I will just make it more clear. Iron meteorite, as you can see here, and also the mantle. The core is surrounded by a mass of solid rock called the mantle. It is rich in iron and very heavy, but not as heavy as the metallic core. The mantle rock is extremely hot, and this makes it moldable, like modeling clay. The intense heat deep within the planet keeps the mantle moving very slowly in currents that cause earthquakes and volcanic eruptions. So basically, as you can see here, this part of Earth is the inner core. Is a ball of solid metal and extremely heavy, as you can see here, inner core. Now let's move to another slide here. Let's move up so you can see it better. Earth is a mass of searingly hot rock and metal with thin, brittle shell. Now, here you see some facts. Diameter of the inner core, you see the readings here. Let me just make it bigger so you can see it better. There you go. Sorry for inconvenience, but I hope you understand. Now, as you can see here, the readings and all the facts actually. Diameter of inner core, very big one, right? Wouldn't you say? Depth of the outer core, there you go. And depth of the mantle, which is also here. And the depth of the crust, which is like 7.7 kilometers or 2,900 kilometers depth of mantle, 2,266 kilometers and 2,044 kilometers with regards to diameter of the inner core. Now it's super big. We are talking big numbers here. Now, seismic waves. Now, seismic waves, some waves blue can pass through the core, but others red cannot and must go around it instead. So here's another thing that I want you to understand. Now, pressure and heat. Now, as you can see, you feel pressure sometimes when you fly with an airplane, and I will show you in much greater detail right now. This is very important that you see it. Let me magnify it better so you can see more and cover more. Let's go through it again. The rock deep within the planet is far hotter than molten lava, but it is kept solid by intense pressure. It's similar to a bottle of soda, as you can see here, bottle of soda. It's similar to a bottle of soda. As long as the cap stays on, high pressure inside the bottle keeps it liquid. But if you release the pressure, some of the liquid turns to gas that fizzes out on the top as you open it, like this. Psst, there you go. Now, planet Earth or earthquake clues. Now, it's a bit kind of like a seismic activity, if you will, but again, there are some things that I want you to understand. We only know what lies beneath Earth's crust by studying the seismic waves that radiate from earthquakes. These waves pass at various speeds through the planet, but can be blocked by its different layers. The science of interpreting these earthquake clues is called seismology. So studying of earthquakes is called seismology. Now, as we move to the next stage, I want you to focus on the fact that Earth itself is a very big, large, huge ball, bigger than the one you used to play football with, but still, it's interesting to note that Earth is still a mystery to us. So, to conclude what I was saying, coming back to our previous thing I mentioned earlier at the beginning of our video, that everything is connected, and I'm coming on 6 minutes now. As Earth cooled, most of it turned to solid rock. So basically inside our planet, it's a very unusual activity. I hope you learned something from my class. Send me projects on inside our planet if you have chance. Thank you so much for your time. Thank you for inviting me in your home. I hope it was worth it to listen to me. Thank you so much for your time again. Be strong and stay healthy. Goodbye.